we have to solve this inequality here. 6 minus x is less than or equal to 3x plus 10, and 7x minus 14 is less than or equal to 3x plus 14. And so what we can actually do here is just solve each individual inequality first. Then when we get our answers, we're going to combine them. Remember, it says and, so both of them must be true. In other words, both of them must be true for it to be a solution of this inequality. And so we're going to solve each individually. So here I have the first one. I can move the 3x to the left to get negative 4x. And I subtracted both sides by 6 to get 4 on the right. And now I can divide both sides by negative 4. And I get negative 1 on the right. But remember, if you divide or multiply by a negative number, you have to flip the inequality sign. So actually it's going to be x is greater than or equal to negative 1. And for the second one, 7x minus 14, blah, blah, blah. What I'm going to do is I'm going to move the 14 to the right, add 14 to both sides to get 28 on the right, subtract 3x from both sides to get only 4x on the left. Now isolate x by dividing by 4, and I get x is less than or equal to 7. And so now I have these two conditions here. X has to be greater than or equal to negative 1, so greater than or equal to negative 1, that's the right, and less than or equal to 7. And so if we graph this on a number line, you can see that the solution is any number between negative 1 and 7, including negative 1 and 7. You can even write this answer, you can combine it to say negative 1 is less than or equal to x, which is less than or equal to 7. In other words, x is between these two values.